If x is negative 2, then y is negative 39. And for simplicity, I'm just going to borrow this section here. But if x is negative 2, then y is somewhere way down, like negative 39. And if x is negative 1, then it's like negative 11. So let's use multiples of 10 here. So if I'm negative 39, so negative 2 is negative 39, so somewhere down here. And then negative 1 is negative 11, so let's say somewhere here. And then we go, so basically we go up, and then when x is 0, y is 1, right? So at that point, so something happens between negative 1 and 0 where it crosses the x-axis. This is really important here. So when x is negative 2, y is negative 39. So you're somewhere down there, right? So we come here, and we say if x is negative 2, we have negative 39. So let's call this negative 39. So it's close to negative 40. If x is negative 1, you have negative 11. When x is 0, y is 1. So from this point to that point, you have to cross, you have to pass through negative 1 to 0. And the question is asking, specifically, it says, at what point, right, this value must have a root between which of the following x values. So between which of these x values, like is it from this one to this one, or 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 from this one to this one. So in any one of these intervals, at what point does the graph pass the x-axis? Does that interpretation make sense? When it says it must have a root between, it means at what point does it cross it? And clearly, when you went from negative 11 to 1, it would have had to cross it in between that space. So if it's crossing it in between this space, the x values that correspond to that are x is negative 1 and 0. So that's the range that's the area where it crosses. So the answer would be negative 1 to 0 for that particular question. It crosses, the root occurs in that interval. Very good. And I'll check the notes later, but right now we'll just move on to number 9. In number 9, it says the system of equations, you guys see that one? Y is equal to x minus 1 squared. And then the other one is y is equal to x plus 1 squared. Has how many points of intersection? That's the question. It has how many points of intersection? So in this particular question, when you're dealing with x minus 1 squared or x plus 1 squared, there's something called graph transformations that is used here, right? So graph transformations, nothing too fancy. The idea is that a graph can move to the right, it can move to the left, it can move up, and it can move down, right? So for example, if somebody says, what is y is equal to x squared? You would draw a u, right? It looks like a u, it's called a quadratic. If they say, what is y is equal to x squared minus 4? You just take this graph and you move down 4 spots. That's all you do with graph transformation. You just move it down 4 spots, and that's the end of it. So graph transformation involves moving a graph up, down, left, right. So here they're asking, what are the points of intersection? And this would apply to, you remember when we did systems of equations, where you would have like a line here and a line here, and that was your point of intersection, that was your solution, right? And so the point of intersection would be the solution to the system of equations. In this particular question, it's x minus 1 squared and x plus 1 squared. So remember, the graph for y is equal to x squared is basically a u that goes over here. But now it says x minus 1 squared, so you have to move that graph, okay? So in one of the cases, you're moving that graph to the right, and in another case, you're moving that graph to the left. So you're moving one of them to the right, one of them to the left. This is not drawn to scale, but these actually intersect at a specific point. So you move one graph to the right one spot, you move one graph to the left one spot, they meet at a specific spot. That's the question that the question is asking. And the options they give you are 0, 1, 2, 3, 4. They intersect at the point 0, 1. So at 0, 1, they intersect. Now, sketching graphs is fine, but if you want to be more specific, what would you have to do with these values? You'd have to use a table of values, right? You would have to do like this, you write down x values, and then you say y is equal to x minus 1 squared. So in this case, you would have a situation where you put in, like, let's say -2, -1, 0, 1, 2, and you basically plug in those values. You have -2 minus 1 squared, you have -1 minus 1 squared, and so on and so forth. So you can plug the values to get the graph, but sketching graphs is actually way more efficient. It's quicker, it gets the work done. All you're doing though is just graph these two things, show us where they intersect, and that's all you need to do for this problem. So go ahead and take notes if you want in terms of the sketch. As I said, your notes will be very helpful as we go through these. So that's number 9. The solution is at 0, 1. If you have graphing paper, you can do this on graphing paper to see a more exact value on graphing paper. Okay, very good. So I'll let you take notes on that while we get ready for number 10. Before I mention number 10, your book, I see, does give you a very good idea, which is where you can set these two equations equal to one another. You would have to foil, set them equal, and then see where those values match. And so using that approach, they are able to get the answer also as well. So, okay, number 10, rules of exponents. We've talked about this like from day 1. The rules of exponents, basically, there's a standard list of rules of exponents, and each one of them has certain properties. And one of the properties of the rules of exponents is that if you have a negative exponent, you can bring that thing downstairs. So in this first case, x to the -2 power would be the same thing as, actually, I'll let you guys go ahead and show, what would I do first in that? Let's show it in your notes. If I have x to the -2, I can make that into a fraction, right? Like a fractional exponent. So that becomes 1 over x squared divided by 1 over y to the first power. So now I've created a complex fraction, which was covered in your Tyler Wallace text. Again, the CLEP test is basically a lot of Tyler Wallace reworded, right? And now we're just trying to use all the tools you've gained all year into one set of tests, right? So this is stuff we've done over and over again with complex fractions. You could write this as 1 over x squared divided by 1 over y, which is 1 over x squared times y over 1, right? And then this just becomes y over x squared. So let's go ahead and write that down for number 10, okay? So that's number 10, basically using the rules of exponents to get the answer that we need. While you do that, I'll get number 11 ready. 2 negative 1 and 2. So basically, with this next one, I'll let you make sure you have this. So this over here, we just use the rules of exponents. We use the negative exponent property. We moved it down. We use complex fractions here, setting this divided by that. We got that. We changed the y there into 1 over x squared times y to the over 1, and then we get y over x squared. So that's number 10. In number 11, they give you 2 points, and they said write the equation of a line. So find the equation of a line passing through the points 2, negative 1, and 4, 2. We've discussed the slope formula before. That's what you would want to do first, is find the slope. So that is y2 minus y1 over x2 minus x1. So that is equal to, so you have y2 minus y1 over x2 minus x1. So that is therefore, you have to label x1, y1, x2, y2. So you label this x1, y1, and x2, y2. So you take those values that match each of those. And please remember that you can label this as x1, y1 and this one as x2, y2. That is legal. It doesn't matter which one you label x1, y1 or which one you label x2, y2, but you have to stay consistent. And that's another big theme of mathematics, consistency, right? You want to stay consistent. Whatever you do here, make sure you do it here. So x1, y1, x2, y2, now we substitute that into the slope formula. So what is y2? y2 is 2. What is y1? y1 is negative 1. So we do that. Divided by, what is x2? x2 is 4, and x1 is 2. So let's see, you see, so the first step to find the equation of a line is to know what the slope is. So the slope is y2 minus y1 over x2 minus x1, and that's how we get those values there. This then becomes 3 divided by 2, right? So we found the slope. That's the first step. Now the next part of the equation of a line is to know the y-intercept. And so if we know the slope, we can try to use the point slope form. We could also we will start with the point slope form and then end up with the slope intercept form. So the point slope form of the equation of a line is y minus y1 is equal to m into x minus x1. That might be our quickest way to get to the destination. The slope intercept form of the equation of a line is y is equal to mx plus b. So that's the slope intercept form for the equation of a line. Okay, so let's go ahead and use the point slope form. We can use the value here where it says x1, y1. So this will become y minus, what is y1? Negative 1 is equal to 3/2 into x minus 2. So all I did was I chose one of the points. So first step was I found the slope. Then the next point is I take one of the points and I use the point slope form of the equation of the line. And so this becomes y plus 1 is equal to 3/2 of x minus 3. So basically I distributed this 3/2 into both things here. Okay, so y plus 1 is equal to 3/2 of x minus 3. I can move this positive 1 to the right side by subtracting 1 from both sides. So now I have y is equal to 3/2 x minus 4. When I do that, I have found the equation of the line. So what was the first step? The first step was I found the slope. Using the slope formula. Nothing too fancy. y2 minus y1 over x2 minus x1 is called rise over run, chapter 2 of Tyler Wallace. What's the next step? I use the point slope form of the equation of the line to plug in one set of points into the formula and the slope. So I plug that in, it brings us to the destination by just solving for y, as y is equal to 3/2 x minus 4. So that's how we do that particular problem. Very good. So that was number 11. We'll now go on and do number 12. The one more thing I will tell you when you do the equation of a line, let me see. When you do the equation of a line, you can have a situation where you can write it in standard form. So you have standard form, slope intercept form, and point slope form. So there's multiple ways to get to that destination. So just keep that in mind as you do these problems. Okay, number 12. In number 12, the question is asking if f of x is x squared minus 4x plus 10, so f of x is x squared minus 4x plus 10, and g of x is 2 minus x, so g of x is 2 minus x, absolute value. Okay, so they've given you f of x and they've given you g of x. What is the value of f of g of 5? What is the value of f of g of 5? That's what they're asking you for this question. What is the value of f of g of 5? Okay, what is the value of f of g of 5? Let's go back here, number 12. Let's see. Okay. Well, they actually gave it to you. You just wrote it in this format, which is the same thing, which is fine. So they gave it to you in that format, f of g of 5. In this particular question, the best way to go about it is to take g of x. Remember, this is called composition of functions. Tyler Wallace again, which is chapter 10 of Tyler Wallace. Chapter 10, Tyler Wallace. Okay? So I know it's sometimes when you're learning something in one particular textbook, you learn it, you practice, you keep it somewhere in your brain, and then you go to a standardized test and you might say, well, I've never seen this. Well, actually, you have. It's just now in a question form. So this is composition of functions, chapter 10 of Tyler Wallace. You take the value of the g of x and you substitute it in for x in f of x. That's how it works. But before you do that in this particular question, they ask specifically, what is f of g of 5? So that means you take the 5 and substitute it in for g of x, and then you take that answer and you substitute it in for x. It's like multiple layers, right? It makes it more fun. So the first layer is what is g of 5? That's the first thing we need to figure out. What is g of 5? Well, we know what g of x is. That's g of x. So g of 5 would be this work that we're doing right here, which would be plugging in 5 in for x. So you have g of 5 is equal to this, which is basically equal to that. So I try to show you every step there so that if there's any issue along the way, we can treat it. So g of 5 is 3. So if g of 5 is 3, then I want to take that value and plug it in for x. Everywhere I see x, that's where I plug in that value. So in that case, we basically have f of g of 5 is equal to, now remember this part here is 3, right? This g of 5 is 3. So take that 3 and substitute it in for x. So that becomes 3 squared minus 4 times 3 plus 10. The rest of this is arithmetic, right? So what's 3 squared? We have 9 minus 12 plus 10. So 9 minus 12, negative 3 plus 10, we have 7, which is a perfect number. It's a great number. Okay, so that's how we use the composition of functions to find the value of f of g of x, right? I'm getting your brain to pull that out from stuff that you've learned before. And so take good notes on this. It'll be very helpful when you take that final. Okay, I'm going to end on a lighter note. 2 lighter notes here. Actually, 13, 14, 15. Why don't we just end on 15? Number 13 is actually about domain of functions, which just means that you can't have negative 1 in the denominator. That's really what it comes down to for number 13, when they ask us about the domain. So I'm going to write 13 and then I'll let you finish your notes and then we'll transition out. Let's see. Okay. So number 13 is the square root of x plus 2 divided by x plus 1. So basically we know that x cannot equal negative 1. Like right away we should know that. And so when they ask us for the domain, that is something we should keep in mind for sure. Let's see. It will be good to know interval notation, which we've discussed before. And so what I'm going to do with these videos is I'm also going to link a longer video to each problem. So that way, if somebody's like, I need more time with this concept, they can go back and watch those videos as well. The largest value problem. Largest value problem. Okay, so let's just look at that 13. Basically, x cannot equal negative 1, but in your answer, they don't give you an option that just says that. So you have to use interval notation, knowing that basically you have to come from, well, actually, the problem has 2 problems. The first problem is this denominator piece, where you cannot have negative 1 in the denominator. The other challenge is that you have this radical piece, where you cannot have a value that is going to make that radical negative. And so the answer in interval notation that will fit both of those is this value. So any value from negative 1 to infinity will be true for this problem. Any value from negative 1 to infinity will be true. The value negative 2 is important here because if you put negative 2 here, it will make this a square root of 0, and that's fine. But you can't just put any value in terms of, if you put negative 1, you would have a problem because you would have a problem in the denominator. So from negative 2 to negative 1 will be fine, and then from negative 1 to infinity, you'll be fine. So that's how you handle number 13. I'll just say something about number 15, and then we'll wrap up with this one I already have on the board. Number 15 is just saying which of these is not a function. You guys remember that a function has to pass the vertical line test. So if you fail the vertical line test, then you have a problem. And what is the vertical line test? It's that it only crosses the function once. So number 15, basically you have to pass vertical line test. So for number 15, I'm just going to say vertical line test. So use the vertical line test. If you draw a vertical line for a function, if the function goes like this, and if I draw a vertical line and it crosses it more than once, it's not a function. Number 14, which is where we'll end and then we'll take a break, is basically asking you to find the largest value of the 5 options that are given in that problem. How do you find the largest value? You literally have to do them one by one. So what is 4 factorial? 4 times 3 times 2 times 1, 24. What is 6 factorial over 4 factorial? You do the math there. What is 7 factorial over 5 factorial, 2 factorial? You do the math. You write out 7 factorial, you write out 5 factorial. Here's the thing I will tell you about factorials though. 6 factorial over 4 factorial. Notice that you can cancel the 4 times 3 times 2 times 1. Just cancel all of that over there. And that leaves you with 6 times 5, which is 30. The factorial idea is just take the number and multiply down until you get to 1, right? So that's how you do 7 times 6 times 5 times 4 times 3 times 2 times 1. And then you have 5. See this trick in math? I'll just write 5 factorial here, and I'll just cancel like that. Notice I don't have to write 5 times 4 times 3 times 2 times 1 in the denominator, because that's going to eliminate that other part. And then all you're left with is 2 factorial, which is 2 times 1. 2 goes into 6 3 times. 7 times 3 is 21. Okay, so there's 5 options that you're given in this problem. We've done 1, 2, 3. There's 2 other options. So I'll let you finish those 2 and then we'll stop. And so basically notice that the first option is 24. The second option is 30. The third option is 21. So A, B, C, so far, B is leading right now. The fourth option, which is 8 factorial, divided by 4 factorial times 4 factorial times 2 factorial. You can write 8 times 7 times 6 times 5 times 4 factorial. And the 4 factorials go away. So that leaves you with 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1 times 2 times 1. Again, just do the math there. And then the last one is 20 factorial divided by 19 factorial. Well, 20 times 19 times 18. All of that is going to cancel to 19 factorial. So try 5 of them, and all it's saying is which one is the largest value. So I'll let you guys decide what the largest value is after doing your work, but I think that's a good place to stop.